All right. All right, what I want to do today is go over the next time we meet. Well, we're not really going to meet, is going to be Tuesday, because there is a we've got an exam on Tuesday. So I wanted to just go to our page and just talk a little bit about the exam. I think it's pretty self-explanatory, the information that I've got posted, but nevertheless, sometimes it is comforting to go through that. So let me get here. I've got a lot of windows open here. Okay. All right. Let me do, I like to do the view of the student. That way I make sure I know what I'm seeing exactly. I'm seeing exactly what you're seeing. Okay. And we are in week, gosh, it's only week 4, right? Gosh. Okay, so we are here and it is Thursday. Great. So today I have a lecture posted here. Let me just go over some of the days. I have a lecture posted today where I kind of need to make a little bit of headway into chapter 3 before exam 1. So I just did kind of it's not really an introduction, it's a little more than an introduction, but the first 16 slides of chapter 3, which is today's lecture, will be potential material for exam 1, but it won't be a super deep dive into slides 1 through 16, but there are going to be at least 1 or 2 questions about today's video that I posted that will be on the exam 1, which is on Tuesday, by the way, September 22nd. And then there's a homework that's due this Monday, and I didn't realize this, but I do not have, I didn't have it actually posted, or I did have it posted, I just didn't have the answers posted, or I didn't have it visible. I can't remember. Today's a very big blur for me for some reason. I don't know, a lot going on. So the answers to this homework, which is due Monday the 21st, they will be posted pretty soon. I'm actually going to work on the solutions after our meeting today, and then hopefully I'll be able to get them up. A little bit different homework though this time. I have these Bielis notes. It's a PDF file of, I've mentioned it before, notes from a professor that I had. And he's got like 2 sets of questions in the Bielis notes. He's got these questions with an S in front of them, which are self-study questions. And then there's the other more involved types of problems. So this is the first time I've given a homework set that actually has the self-study questions. And I wanted to go here. Let me open up I want to open up the Bielis notes and show you that. Show you something. Hang on a second. You won't be able to see them just yet, but soon. So you can start working on those Bielis notes problems, but those self-study problems, what's kind of cool is the answers are already in the document. So where is it? I think it's right at the end though. Give me a second here. I forgot to look for this. Where is it here? So in the PDF document on page 251, there are the answers to those self-study or self-test questions. So I wanted to point that out. So I won't actually be showing the answers to those. They're already in the Bielis notes. But then there's 2 problems in that particular homework set that you do have to do that I will show the answers for. All right, now I'm going to go back to our page. Whoa, man, where is it? There we go. Right there, is that it? Okay, that looks good. You can all see that, right? If you can't see it, chime in. Okay, back here to the modules. And then that's the end, right? Okay, there we go. Then I want to go to the next week, which is week 5. Not that. Okay. So I actually have some suggestions for Sunday, is because our test is on Tuesday. So please make sure you go over all of your missed quiz questions. I think most of you have been doing that. Always try to discipline yourself too to read the announcements, although I don't post that many here. and keep working on that homework number 4. What I recommended to some people that I met with this week, when you're doing the homework, because I know it's easy to not do the homework because it's not graded, but the homework is there so that you can remember how to do some things that we need for the new material. I said this before, but my best advice on how to do the homework is to do a few of the problems, get the answers, and then look at the actual answers. So I know that when I was, especially an undergraduate, I would try to do the homework problems. If I had the answers available to me, I would work on the homework problems and kind of reverse engineer them, like look at the answer and then kind of back into it. What I really think is better for you to do is to do a few, then check your answers, figure out which ones you got wrong, and then figure out why you got them wrong. And I think that will be a more productive session for you. So please do that. Now, on Monday, make sure you understand what's going on for exam 1. This class is very responsible. I'm not concerned about you at all, but if you click on here, you've got the whole exam 1 information page. And I did want to talk about some of the things here and address any questions that you might have. I've got most of the exam prepared, and it's going to cover material. It says chapter 1, but there's really nothing in chapter 1. There's a little stuff, but chapter 2, and then again, just those 1 through 16 slides from section 3.1. And then it covers homeworks 1, 2, 3, 4, and then the first 3 quizzes. Now, there's not going to be any questions about the syllabus on exam 1, even though there was on quiz 1. Be about, I don't know exactly how many questions I'm going to end up with. The number of questions depends on how long the exam is taking me to do. So for those of you who have never had me as a teacher before, what I do is I use a rule of thumb in these types of courses. It depends on the course, but I make up an exam, I leave it alone for a couple of days, and then I take it. And I have to take it in a fraction of the time that I expect that I'm giving the class to take the exam. So for example, this type of a course, I would say a ratio of 1 to 3 is probably appropriate, or 1 to 4, meaning that I have to take it in 1/3 to 1/4 of the time that you're being given for the exam. If it takes me longer than that, then the exam is probably too long. And I use different ratios for different courses, but this course, that seems to be about the right ratio. There will be a first, right here, the first question will be a question, just like you're answering on the quizzes, is kind of a given point. Here you're going to get a given 5 points, so you'll be asked to, do you understand the academic integrity rules for the exam? And the exam will then be out of 105 points, but it will be scored out of 100 points. So for example, if on this exam you were to score, as I say here, like an 86, it's an 86 out of, 105 points, but your score is going to be rated as 86 out of 100. So it's like, it's the little extra freebie, extra points, and that's because I don't have the ability to do as much partial credit grading on these exams as I would like to do. There will be some partial credit on this exam, but I'm limited because I don't have a teaching assistant, and I have to use efficient time. I've got 500 students this semester, so I've got to figure out how to be as efficient as I can. Here are your musts, and you know how these things go, but just like with the quizzes and everything's cool here, you guys are doing a great job of keeping your hands on camera and doing everything. So you gotta have a webcam, you gotta use the lockdown browser, make sure your calculator usage is on camera. One of the things, I haven't really been checking these because I kind of know who you all are, but when you're prompted, I don't know if this has happened, I haven't checked this, but if you're asked for photo ID, which you are on the browser, don't show like a debit card. That's just to protect you so that you don't I'm not going to steal your credit card, but if it's out there, maybe somebody could see it. So if you're going to use a photo ID with a debit or a credit card, at least cover up the number if you would. Let's see, all of this, all of this, all of this. Same rules. I need you to get into the exam. I give you like a 10-minute grace period to get into the exam. I usually open it up a little bit early if you want to get started, so that's fine. Here I have these mays, the may nots, the must mays, and the may nots. So the mays are in green, meaning, green is for go. Same rules as for quizzes, but here's the problem though. With the lockdown browser, and I just learned this a couple of weeks ago, they allow me to whitelist certain websites, except it doesn't work all the time. So Dr. Jennings has been able to use Lockdown Browser to whitelist like PDF files that are out on the internet, but she and Dr. Clough and myself this week tried to whitelist and use our Urban OR online text, and none of us could get it to recognize it. So I know that it'll look like it opens and then it closes something else. So since I can't let you, with a lockdown browser, won't let you go to the site, what you may do is you can print out as many pages of the text as you think you need. Now, you know we're not covering all of the text, but if there's some formulas in there that you'd like to have on the site, please just print those out. You can have those available to you during the exam. And again, you can have as many hard copy paper slides or handwritten notes as you'd like. It's perfectly fine with me. Is there anything under the may nots that I want to point out here? Let me see. You guys are all following directions, so I don't think I need to go all over any. There's really nothing different here than is for a quiz. So wanted to point that out. Oh, okay. Now, any questions about the exam that I can answer right now? Nope. Okay. A little reminder that in the syllabus, we don't have a cumulative final in this course. I do believe in cumulative finals, but this course is an elective, I'm calling it an elective course, but it's part of people's career focus area if you're an undergrad, and it's not a required class. So exam 1 will cover all of the stuff up through today's lecture. Exam 2 will start with next Thursday's lecture and go through whenever exam 2 is, and so on. So there'll be 3 compartmentalized exams here. Now, the other thing that I wanted to do was I put together this morning some questions that might show you what you might, the style that you might see on the upcoming exam. So let me go back to the page, and what you might want to do now while I'm talking is go to the page and then click on the link that I am about to show you. So go to our page. Let me do a share here, hang on. All right, so we're going to go to the page for this week. So the week 4 to-do list here. And I just added this. So you probably have looked at this page before, but I just added this. Right under here, Thursday, 9/17, I made a little, like, it's not really a quiz, but I put it in quiz format. So these are sample exam 1 partial credit questions. So I'm gonna click on that in just a second. So in the quiz questions are kind of like you could kind of expect for the exam. Thus far, you've seen quiz questions that are numeric entry, so you're familiar with that format. You've seen quiz questions that are multiple choice, so you're familiar with that format. And I gave you a little partial credit question on this past quiz 3 where you had to show the joint probability density function for X and Y. With the exam, what I know that students like to have partial credit, I like to have partial credit. So there will be more partial credit questions on the exam than you've seen proportionally on the quizzes. So let me just show you what I did here. So if I click on partial credit questions here, and I had started this, it's not really a quiz, I just put it into quiz format. If you take a look here, I took some questions from quiz 1, 2, and 3 that you're already familiar with, or there's some question pools in there, maybe you've never seen them before, but what I did was I took some questions from quiz 1, 2, and 3, and I put them into a partial credit format as if they were part of an exam, like exam 1. So just so you know, you're not going to get these questions. Sometimes teachers do that. They like do a review and then all their questions on the review end up on the exam. That's not what's happening here. I took quiz questions and I re-chewed them so that if they were on an exam, this is what they would look like. So here we have question 1, and I think this came from your first, it came from your very first quiz. And this was where we were looking to see when a ferry would be full. So what I did here, if this were to be on an exam, it says determine the following and place your answers in the space below. So the part A says define the random variable needed in words, and then part B says what's the probability that the ferry reaches capacity in the first 30 minutes or so. And you know what I want to do here? I want to simulate something. Give me 1 second here. I'm going to put my computer down on the ground here on the desk. Okay, let's see if I can do this. So if I were taking this question as an exam question, then I would, let's see, define the random variable as needed, and I would say, let's say part A, X is the time, elapsed time until the ferry is at capacity. I mean, there's many ways that you could have said this, but you would just type it in here like this. So X is the elapsed, spell that right, time until the ferry is at capacity. And then part B says what's the probability that the ferry reaches capacity in the first 30 minutes. And then this is where I don't want you to get too freaked out, but it says clearly identify your answer and explain how you got it. So what do I mean by clearly identify your answer? That means don't show a bunch of equations all with different answers and expect me to know which one you intend to be the final answer. I don't anticipate that from this group, but like often, what will happen, because I did this myself, is I'm like, okay, should I use, for example, this question happens to need to be solved using an Erlang distribution, but a lot of people might be like, oh, is this Poisson, or is it exponential, or is it Erlang? And then what they might do is they might solve it in some fashion using all three of those and then hope that one of those three is the right answer. So your answer has to be very, very clear. So don't just throw everything, you know, the phrase is like you throw spaghetti at the wall to see if it sticks, to see if it's done. So don't throw everything at the wall here, commit to one thing. So for part B, to determine the probability, once I've defined my X, this would be, there's a number of ways that you could convince me of your answer, but you might want to type in, you don't have to do a whole lot of stuff here, but you might want to say like something like this, X is Erlang, and then you're trying to find the probability that X is less than 30 minutes. And then depending upon how much information you want to give me and how much time you think you have left, you could go ahead and show the whole equation if you'd like, or you could just write down what the answer is. So we know that when X is Erlang, this is probably how I would do it if it was me taking my own test. I might say like 1 minus, and I know that I need the CDF of a Poisson random variable, and using my own notation, if you can go up here and you can use some of this, you don't have to get fancy, I really don't. Use exponents as the caret or whatever. But if I wanted to do a subscript here, I could click on the subscript here and say, I need the CDF of a Poisson random variable, and it would have to be evaluated at the number of exponentials that I'm adding together to get my Erlang random variable. So there are 15 inter-arrival times, but then we subtract 1 from that, and then I would be I would use for this Poisson, this lambda Poisson, I might just type in this just like this, using lambda equals 1/3 times 30. So where'd the 1/3 come from? Well, in the problem it said that my tourists are arriving to this ferry at a rate of 1 every 3 minutes, and we know that that's the rate of the Poisson arrival process. So this would be sufficient showing the work, or even more, it's more than enough, but then the actual answer to this, and correct me if I'm wrong, but it should be 0.0835. So that's pretty clear to me. Now, if you had another number down there like 0.8372, it's not perfectly clear to me what the answer is. So just make sure that you know that I know what the answer is. And if you really want to be clear, you can do this. You can just make a little arrow there and say answer. But don't spend too much time in the box here. Just do as much as you think time can allow that's clear enough. Can I answer any questions about this problem? Okay. Those of you who've had 385 with me, I think we did a little bit of this after we went to online only last semester. I think I was able to do some of these partial credit ones. Also, if you want, so here's the thing, you're not allowed to take pictures of these things, right? So please don't take any screenshots of this. I'll tell you what, you can take a screenshot of the answer if you want, but don't take a screenshot of this question, please, because I might have to use it in another course. Okay, question 2. I think this one came from, is this from quiz 2 or 3? Doesn't matter. So now we've got a random variable here, time between arrivals of a tram in a theme park, and it's and I gave you a PDF for the time between arrivals that was 2 times t. Typically our time between arrivals, we often model it as exponential, but when I was trying to see if people understood the idea in this problem, I think in the quiz it was about random incidents, but anyway. So it says determine the following and place your answers in the space below. So same idea. So here's part A. Now notice it doesn't say show your work. I mean, you can go ahead and tell me how you got the answer if you'd like to, but you should be able to know how to do expected value and variance, but there is partial credit here. So part A is 3 points, and the right answer to part A would be, and it said 2/3, and it says include units in your answer. Now, if you put down the numerical answers for A and B, and these are the correct answers of 2/3 and 1/18, the total question is worth 6 points, but you are only going to get 3 or 4 points for this problem because I want to know that you know the units. So what are the units on part A? Now we can interact a little if you want. Anybody?
Time.
Hours.
Right, it's time, but right. So if you put time, that's not going to work, but hours will work. And how about for part B?
Hours squared.
Right, and it would be perfectly fine to write hours and then just use the caret because it's a little bit faster. But as I said, you could also use, you can use these super and subscripts up here if you're comfortable with that. So that's what that's an example of partial credit, but it doesn't say like explain how you got your answer because I would hope that you know how to get expected value and variance. I was wrong about that in one quiz, but I think you'll know by the time Tuesday rolls around. Any questions about this one? Now, on the exam, I want to be clear too, is there will be some that it will be answered quickly. There may be some numerical entry and there may be some multiple choice as well. But I will be able to go through and grade these partial credit ones pretty quickly. There's only 19 of you in the class. I just can't do as much partial credit grading as I would like if it was a paper exam. So here's another question. ASU's got this delivery vehicle. Have you guys seen those on campus? They're kind of cool. I know NAU has them. Has anybody used one of them yet? You know what I'm talking about?
I've seen them, but I've never used one.
I only saw one the other day, but I saw that they're all over the NAU campus. They're everywhere. Anyway, we'll see if it works. Okay, so we've got X here, and here the problem defines what X is. X is the number of times in a day that the vehicle picks up food from, and I just threw in the Chuckbox there. So it says that this vehicle will either have 0 orders from Chuckbox or 1 or 2. And somebody has given you the CDF. So this is really a 380 concept question to determine if we all kind of know how to go from a PMF to a CDF or how to go from a PDF to a CDF, right? A PMF, we add up probabilities to get the CDF, and for the CDF to get from a PDF, we would do an integration, but we don't often ask you to do it backwards. So what we are trying to ask here is if you were given the CDF, could you get the PMF of this random variable? And it's pretty clearly a discrete random variable. So if you were asked, for example, and this is a potential, in the space below, show the PMF of X, this is how the best way to show it would be. Remember, whenever you're asked for a PMF or a PDF, always remember to put the range on it. And so a way that this question might be answered, and a number of people miss this, by the way, on the quiz, so you might want to remember how to do this. So the PMF, I use the notation of lowercase p x the textbook that we use for our undergrads uses a scripted F. That's okay too, but, and that would be perfectly fine, but the probability mass function of X in this case is going to be, and I always recommend doing it this way. First determine what your random variable can equal. So we know that X is allowed to equal 0. So for anybody who got this right or got it wrong and figured out why, what is, from this CDF given in the problem, what is the probability that X is equal to 0? Can someone tell me?
0.35.
Right. So that is 0.35. Then the next value, and look, don't worry about alignment. I'm like super duper, I'm an alignment freak. So you can see me getting a little freaky here. But don't worry too much about it. But the next value for X is that we could have one order from the check box. Can somebody tell me what goes there? Somebody different though. Because a lot of people put 0.8. It's not 0.8. Why is it not 0.8?
0.8 minus 0.35.
Right, exactly. That gives me the problem, because the 0.8 says that X is less than or equal to 1, and the 0.35 says that X is, well, equal to 0. So you have to subtract one from the other. So when a lot of people put in 0.8, if you got this question on a recent quiz, and it's not 0.8, it's going to be, as you said, it's going to be 0.8 minus 0.35, so that'll be 0.45. And then the last last value here, what would the last value be? And when X is 2, what would this be? It can only equal 3. It's 0.2, right? Because the sum of these all has to equal to 1. This is what would be a perfectly fine amount of material to put in that box when it says in the space below, okay? But make sure you have the range on X. So I wanted to give an example of that. It doesn't mean these questions are going to be necessarily on the test. I'm not completely done, but I wanted to give you examples of what you could expect. Are there any questions about this question that I can answer? Question 4, also from, I think, was it the last quiz? It's all a blur to me. I was very busy this week. Can't remember all the things I did. Okay, it says, determine the following and place your answers in the space below. So in words, what is the definition of the random variable to answer part B? So what are we trying to do in this problem? It was that train exchange problem. And we want to determine for part B, what's the probability that we have more than 2 A trains while we're waiting for a B train? So a passenger comes into this terminal and is waiting for the B train. It's accurate to assume that he or she, I said he here, he is going to get on the first B train that shows up. So it doesn't say that that's an assumption, but it's a pretty reasonable assumption. So to answer part B, the probability that more than 2 A trains will arrive before the B train comes, in the box below, and there's a couple different ways you could do this, but this is how I would define it. I would say X, it's almost written out for you though, right? Is number of A trains that arrive before the first B train. And if you had this question on the quiz, I had a couple hints on this one. And one of my hints was that your random variable here is not geometric. Just because the word first is used doesn't mean that you have a geometric random variable. So be kind of careful about that, because that's something that probably would have, mistake I probably would have made. So that is what part A, right here. And then part B says, what is the probability, again, same thing, more than 2 A trains arrive. So explain how you arrived at your answer. So you want to make sure your answer is clear. I should have put that in there. And then how did you arrive at your answer? Now you could get pretty detailed with this one if you wanted to, but I'm going to put in enough information that would tell me that you were at least on the right track. So I would maybe define a couple of events. So I might define an event as A is the event of an A train. So I'm not being beautiful, perfect language here. And I would define B is the event of B train. And you don't have to do that. I don't think you have to define events here, but that would be kind of nice. And then I'm going to say that P, you could subscript it if you'd like. I'm just going to do it this way. PA is the probability of an A train. So we know that that's going to be 1/3. And then I might write, this is me like in a hurry in an exam. I just don't want you to worry too much about it. Just be as clear as you can. 1/3 probability of an A train. And then you might say that PB equals, well, 2/3 is the probability of A. I didn't even spell that right. You get the idea. Also, don't worry about the spelling in this, but A train. 2/3 is the probability of a B train. And then what might be good, since I asked you to define the random variable, is to kind of show the probability that we're looking for here. So what we want is, we want the probability that my random variable, the number of A trains before a B train, is bigger than 2. And when you, that means it could be 2 or 3 or 4, and really it could go on forever. So we might not want to work with a sum of infinite terms here. So we might want to express this as 1 minus, and by the way, there was a homework problem almost just like this. What is the probability that X is less than or equal to 2? So what I'm doing here is kind of showing you what you could put in here as your answer, but what you could also do, I'm also trying to teach the problem in case you missed it. So you could do it this way. You could say, well, this is going to be 1 minus, and then we have the probability of, and you could use intersection here if you want. You don't have to show all of this. Basically, we're looking for 1 minus the probability that X is less than or equal to 2, and we could express that in terms of the way I have A and B defined here. Is we could have exactly 2 trains that arrive before, 2 A trains before the B train. So that would be the probability of having event an A train, and then another A train, and then the B train. So that would represent X equals 2. To get X equals 1, we would have the probability that we are, the first train that comes by is an A train, but then we get a B train. So that would represent X equaling 1. And then finally, X could certainly be equal to 0, meaning that the next train is just a B train. So that would be this here, like so. And that's why in the quiz, I gave the hint that said it's not geometric, because if we define X to be the number of A trains before the B train, X, if it's geometric, it cannot equal 0. And then if you wanted to, you could just show that this is equal to 1 minus, and then I don't know how you could just put these in. So this would be 1/3 squared times however you want to do it. I'm just going to write the numbers here. This would be sufficient to me to know that you did it right. And then if you just wanted to punch in the answer here, it ends up being 1 minus 26 over 27. So it's just 1 over 27. So I guess try to do a balance between giving me enough information that I know you did it right without spending so much time punching in a lot of equations. This would be fine for me. The only way you could really lose points here is what if you you have everything right up to here, but then somehow you did something mathematically wrong and you put in 2/9. That's not the right answer, so you can't get full credit for the problem. But at least I know that your train of thought or your process was correct. So there is that.
Professor,
yes. Yes.
Can I ask a question about this specific question?
Sure.
Because it actually threw me off like super hard, but I got full mark on the quiz, so I think I got it right.
Yeah, well,
So
you wouldn't have
you
gotten
said-
full credit if you didn't get it right, so.
Yes. So you said it's not geometric distribution, but isn't it geometric distribution? Like, it's 1 minus geometric CDF of when
think you-
x is 2 and p is 2/3.
Well, X itself though is not geometric, right?
Yes.
So
Yeah,
the way
x itself is not. Yeah.
This is the way I chose to solve the problem. There could be a way to solve the problem using the geometric distribution. I just didn't do it that way. But I can't use the geometric distribution the way I have defined X here because it can't happen.
Actually, why isn't it geometric distribution, the number of trains that comes before the first B train?
Because
Isn't it like
X could be 0. And a geometric distribution starts at X is 1.
Oh, I see. So if we assume X is the number of train that B arrives, or the number of trains that it takes till B arrives, then we can call that geometry.
I think that would absolutely work. But for me, I don't know, maybe
okay,
my brain, sometimes I look at a problem differently than other people see it, but try it that way. It should work.
Yeah, because I did it. I ended up like, I think solving like 3 different ways and I got the same answer. So
right. In the quiz, I specifically defined X though for you, right? I said right here, I said, where is it here? Did I think in the problem I defined X. I think you did. Yeah, I chewed this one up a little bit differently for this example here today, but I think I gave you X and it wasn't geometric. I'm sure, otherwise I wouldn't have given you the hint that X isn't geometric, I think. Take a look at it, but I'm sure you could solve it that way. That would make sense, yeah.
Yeah.
It's a nice little problem, I like it. Any other questions about this one? Okie dokie. Now, this one, question 5, has to do with that 3.1 material that I said was in slides 1 through 16 that I'm asking you to watch today. And it would have been good if you watched it before attending this little live lecture here, but if you didn't, that's okay too. But I thought I should just throw this one in. And what I'm going to do is I'm going to actually work this problem for you using my dot cam. So what you might want to do, I'm going to unshare my screen here and then switch over to the dot cam to answer these questions. You might want to have a window open to this question and then another window open to the Zoom meeting so you can see what I am doing. So I'll give you a second to do that. I'm going to move my computer here. Back here. And let me get my document camera set up. Hang on a second. Okay. All right, let's see if this works. I hope I have enough light in here in the kitchen. I am going to stop my share. So make sure you've got question 5 pulled up. I didn't print it out for what I'm about to do. So you're going to want to take a look at that for sure. And what I'm going to do is I'm going to go to my document camera here. Oh, stop it. There we go. You should see a white paper. You might want to pin the video or do speaker view. That should work. Let me pin that. Let me do that. I should give us something to focus on. Hang on one second here. Let me get a pen. White pie. All right, now focus, little camera. There, perfect. That is good. Okay, now looking at that question, we had a one mile strip of highway. Let me pull it up on another place here. Hang on. And if you read it, it says that, hang on, I'm pulling this up on another computer, make it easier for me. Oh, it's a 3-mile strip. I changed it and I remember now. Okay, all right, we got a 3-mile piece of highway. An accident can occur randomly on this piece. today's lecture material talks, we started out with a 1 mile piece of highway, and then we went to 2 miles, and we went to just a general length of highway. So here, we've got this strip of highway. And I'm going to call these mile markers. So I'll call this mile marker 0, and then we'll call this mile marker 1, and then this will be mile marker 2, and then this will be mile marker 3. And it says that an accident can occur randomly on this piece. So in today's lecture, we said that when it says randomly, what we're going to do is assume that the location of an accident can be anywhere on this strip according to a continuous uniform distribution. And let's see, it says a hospital is located 1 mile from the 0 mile marker and 2 miles from the 1 mile marker. So what I was trying to say here is that we're going to have a hospital that's located right here. So that's going to be my hospital. And that's fixed. That's not going to be moving. So it says, part A, what is the probability that an accident occurs between mile marker 0 and the hospital? So if we were to define my random variable x, which I always recommend doing, I would say, this is part A, right? I would say just that x is the accident location. And we know it's a continuous random variable. And we also, I'm going to assume the same things that the book assumes, which is that it can occur anywhere, U-turns are allowed, and it's, you know, it's a continuous uniform distribution here. So part A is really just asking me to determine what's the probability that x is less than that 1 or the 1 mile marker there, or between 0 and 1 for that matter. So that's the same thing as saying capital F of 1, the CDF. But let's go ahead over here and put down the PDF. So what I'm doing here is I'm solving this, and what I'll do is in the box I'll put the answer that you're going to want to put down in the box if it was an actual exam question. So you do not have, this is not needed, but the PDF of x, if x is between 0 and 3 miles, if it's continuous uniform, then it has to be 1/3. So you don't have to write that down. In the box, full credit answer would simply be f of 1. And then you know that this is a continuous uniform distribution. And you know that a capital F for continuous uniform is going to be x minus a over b minus a. So when we did this back in 380, and this is b, we have x minus a over b minus a. X just happens to be 1, and so that would just be 1/3. So this would be perfectly great and full credit on a test as a partial credit part. All right, then B says, what is the expected location of an accident? And since the accident can be between 0 and 3, and I recognize it as a continuous uniform, I know that the expected location of my accident is just going to be A plus B over 2. So that's just going to be 3/2. And it says, I hope it says, oh, that's okay. I didn't say include units in your answer, but yeah, the location is at the 3/2 mark here. That's good enough. I didn't say include units because it isn't really 3/2 miles. It's at the 3/2 mile point. So I didn't say to use units, so no problem there. And then part C says, what is the expected distance from an accident to the hospital? And here it says to express your answer as a fraction or to 1 decimal place and to include units in your answer. A little tip is sometimes, most of the time, not all the time, a little tip. Whenever you see me say express your answer to like 1 decimal place, that means that the answer probably only goes to 1 decimal place. It doesn't always mean that, but you can feel better about your answer if it's to 1 decimal place. So what I'm going to do here is I'm going to define a new random variable for this problem. And again, maybe you want to say, it doesn't say to do this, okay? But to be clear, on a test, you might want to just say this, that D is the distance from my randomly occurring accident to the hospital. So what we want is to find the expected value of D. But the thing is my accident could occur over here on the left side of this strip, if you're looking at it this way, or on the right side. So what I'm going to have here is I'm going to have to use that total probability rule. And I'm going to say, well, this is just going to be the expected distance to the hospital, given that my accident actually occurs between 0 and 1. So what I decided to do here as a teaching tool is to also define A is the event, you don't have to do it this way, but it's the event that my accident location X is less than 1. And so A prime is going to be the event that my accident location is bigger than 1. And we're obviously assuming that the hospital has absolutely, takes up no footprint at all here, but that's okay. So the expected distance is going to be the expected distance given that my accident is between 0 and 1, and then I have to multiply that by the probability that my accident is between 0 and 1, and then I have the expected distance given that my accident is between 1 and 3 times the probability that it's between 1 and 3. And we have some of this information pretty readily available here because as part A was on purpose, we wanted to figure out what the probability is that X is less than 1, which is the probability of event A. So we can see that this is just equal to 1/3, and so the probability of A prime is just 2/3. So now what we just have to do is figure out what exactly is the expected distance if we know that the accident has occurred between 0 and 1. So I'm going to kind of branch off over here. You're not going to be putting this in the box, by the way. I'll just write down when I'm done what would look good on an exam. So if I wanted to get this component here, what I really need to do is to use a formula that we didn't really, I presented it in the chapter 2 slides, but I didn't do anything with it until today. So what I'm going to do is I'm going to use one of the formulas, and it actually is in the textbook. It is formula 2.39. So let me just show you what I'm using here. I actually have the textbook here, but you can go to the online text. So whenever I'm interested in a probability of something, here it happens to be kind of a joint probability density function, but it works either way. It also works this way if I'm just conditioning on an event. So I'm going to take and condition on this event A. So what I'm going to do is I'm going to look for what would the density function be as with A occurring along with the original PDF, which is that continuous uniform, and then I divide it by the probability of A occurring. I was looking for a better formula here. Is it in here? Let me just see real quick here. I don't think it is. Let me just double check. Nope. But that's the one I'm going to be using. And again, it was presented in the chapter 2 slides, and I just want to give you a heads up, you know, it's kind of coming out of the blue here. So I'm going to use equation, it was 2.39 in the text. And so if I was interested in FD, and this would be, you shouldn't really be using D, and you'll see why in a second, given that event A has occurred, because I need the PDF of D to get the expected value of D, but you're going to see that it works out quite nicely. What I'm looking for here then is I'm really looking for FD, if I use that equation, and then I divide by the probability of A. So I'm looking for what would the PDF of D be like if we have, and this is not, I'm not doing this super duper great here, but what is this PDF, which is over here? I called it X, but really in this case it's going to be D. So we're going to say if we have D and A occurring basically at the same time? Well, D is just the distance to the hospital, and A is over here. The PDF is just going to be what it is here, which is 1/3, and the probability that A is going to occurs is just 1/3. So this is just going to be 1 whenever my distance is between 0 and 1 miles. So that's kind of a long-handed, not so great derivation of just saying if you're uniform across the whole 0 to 3 miles and you break it up, you're still going to be uniform across the two pieces. It's just you're going to have different limits or different ranges for that random variable. So it's continuous uniform for anywhere between 0 and 3, but given that it happened between 0 and 1, it's still continuous uniform. It's just that it happens to have a numerical value of 1 now instead of 1/3, and a range of 0 to 1 instead of a range of 0 to 3. So now that I know that, I should be able to get the expected value of, right here, let me do it this way. So the expected value of the distance to the hospital, given that my accident occurred between 0 and 1, is just the expected value of a continuous uniform random variable with a equal to 0 and a b equal to 1. And so you should recognize that to just be, that would just be 0 plus 1 over 2. So that would be a 1/2 mile. And then same thing, if I'm interested in the, I'm gonna use a different color. This is good. If I'm interested in the PDF of the distance to the hospital, given A prime, I can show the same logic there. It's still going to be, or excuse me, it'll be 1/3 or 2/3 up here. Because,
Dr. Patton,
yes, I,
paper up a little bit.
oh shoot, I always do that, you know that? There we go. So you could kind of think, let me go back for just a second. The PDF, if we have the accident between 0 and 1, would be, because it's 1/3 there. Now we have it between 1 and 3. So the numerator in this case is going to be that 2/3 over, and then the probability of A occurring, which is 2/3. I'm sorry, it's not 2/3. I just did it wrong. I'm so sorry. Hang on a second here. A prime. I'm sorry, I'm writing down the wrong thing here. Apologies. Eventually, this is going to get to, I'm sorry, I'm looking at my notes here. What did I do wrong here? This works out to be a 2 for 1 less than or equal to D, or it doesn't matter if I use the equal sign here or not, or 3. So where did that 2 come from? It was 2/3 divided by 1/3. That's what it was. Divided by 2/3. What have I done wrong here? That would be the probability of A prime. Probability of A prime is 2/3. I'm having trouble figuring out how to explain that formula here, except logically. Let me think
I
about
think the denominator is 2/3, so then
It
numerator
is.
should be 4/3 for some reason.
Right, and I'm not sure why that would work out. I'm not explaining it. It's not what I have in my notes because I rushed through that a little bit quickly. So hold this thought about where that comes from, except to say that because I have to rationalize how that would have to be 4/3 there, and I don't have anything written down for that to explain it. So I'll send a note about that. It has to be 2 though, right? Or it has to be 1/2. Excuse me. What an idiot I am. The expected value is going to be 2. This is going to be 1/2, right?
Oh, that makes sense now.
Then it makes
because-
sense. Now we've got, right, we've got 2/3 and 1/3. There we go. Yeah, that's what happened. just so you all know what I'm doing here, because I get a little bit nervous because I haven't taught this class in a while, right? So I spent a long time this morning trying to figure out what I wanted to do this afternoon. And so I put together, look, detailed notes, but what happens is I go from here and I start looking at stuff over here, and then I lose my place, which is my fault. Anyway, I should use the same colors and then I won't have the problem. There you have it. Now we know that this is a continuous uniform random variable between 1 and 3. So we can get the expected distance to the hospital given A prime. That's just going to be the midpoint between 1 and 3. That's where my I went. My I went to the 2 here. So that would be at 2 miles. And so now we have everything and we can put it all together now. So now we have the expected value of the distance to the hospital. So this is where I'm going right here. Is now going to be, it'll be the 1/2 a mile times the probability that the accident occurred over here, which is 1/3, plus the 2 miles times the probability that it occurred over here. And then that works out to be, when we do it.
Really quick.
Question?
Can you scoot it up the paper?
Oh, again, damn it. Sorry. Oh, I'm sorry, I swore too, sorry. I swear a lot more in the pandemic than I ever did before. But just feels good some days. So that would be 1.5 miles. So the question is, I mean, I did this kind of to develop it, but going back to if it was on, if this type of a question was on the exam, what would be appropriate to include in the answer box? And I would suggest that it would be enough to do this. I would define this. I might define these. I would show this. And then I would show that. And if you wanted to throw in some other stuff, that's fine. But I was explaining how I went from what the different components are here. So a 100% score, if this was on an exam, would be anything that you have here in yellow is enough to let me know that you did it right. What could go wrong? Well, it's possible that in doing your fractions down here, maybe you accidentally made a mathematical error and this is not 1.5. That would not be a perfect score, but it wouldn't be a whole lot of points missed because the development of this is, I mean, that's where all the meat is, right? So anyhow, so that was what I wanted to talk about today, and then to address any, you know, residual questions about the upcoming exam on Tuesday. Any questions that I can answer?
Yeah, when we take this quiz, let's say we did put all the work in the box. If there's like a highlight or underline feature, could we use that to like label
You
our-
can. Is there? I haven't tried that.
I know there's an underline, but I don't remember if there's a highlight.
There's definitely an underline. I mean, if you want to, I mean, I would assume if you underline something, that would be your answer, right? But I just want to make sure it's clear. So you know what I'm saying, right? I mean, if you put a whole bunch of numbers in a box and one of them's right, but all the others are wrong, I want to know that you know which one is right. So if you underline it, that's a good indicator that it's the right, you know, that's your clear answer. I like to use those little arrows, you know, like, and say answer, but however you can make it clear is best.
Okay, sounds good.
Fair enough, yeah. I think you'll have fun with the test. I don't know, I always like taking these tests when I took the course myself. I like the, I don't know, I like the challenge of taking a word problem and breaking it up into different parts. And anyway, other questions? All right, I'll stay in the room till everybody's gone. If there's somebody shy, and then I'm gonna go teach 380, which is gonna be busy. So have a good day, everybody.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye.
Bye. Unshare my screen.
Hi, I have a question real quick.
Uh-huh.
So I guess my question is that would the expected distance given that x is greater than 1, would that be at the 2 mile mark, or would that be expected 2 miles away?
No, the expected distance is the distance to the hospital. It's not, right? So you could actually think of this if you wanted to, if X is it's the way I did it in the lecture. I should have done it here. I could have done this. I defined D to be the distance from the accident to the hospital, right? So what is D here? D is just the absolute value of X minus 1, right?
Yes.
That will work too.
Okay. I'm just confused how the expected value is 2 miles when the maximum it can be away from the hospital is 2 miles. I guess that's
Oh, I see what you're saying. The expected the distance to, oh, I see what you're saying. Oh, yeah, I see what you're saying there. D, oh, then I have to redo it for this, don't I? Damn it, I made a mistake then. That's all right. So the expected, I see what you're saying. I got it. I know what you're saying here.
as long as I'm not going crazy.
No, you're not. And you know
Looking at
what?
that and I was like, I don't know how that makes sense, but
No, what happens is, what happened was I was trying to come up with a good problem to do today, right? So everything's cool till here, right? And I thought, oh, I'll try something I've never tried before. And I obviously didn't fully vet it. So let me rework that one. And you know what I'm going to do? I'm just going to repost, I'll repost it. So that's 2 mistakes in 2 weeks in a row. Irritates me. But if I define it this way, then it'll work out, right?
yes.
Right.
So then it would be 1/3 times 1/2 plus 1 times 2/3. Is that
Well, I'm
correct?
going to have to rechew it for this here. So what I see what happened here. So
Because the first expected value would stay the same since it's -1.
right. No, you're right. So the answer would be, I see what you're saying, right? So the expected distance, can I use another piece of paper?
Yeah.
Let me use another piece of paper. Then I don't have much to do then. So if I want the expected distance, I'm going to just write it down again, right? The expected distance given A times the probability of A plus the expected distance. That's what I did. I didn't define D to be X minus 1. That was the only thing I left out. There, right? Okay. And then everything is cool here so far, right? We have, this would be 1/3. This is 2/3. You're cool. We're good with that, right?
Yeah.
So if the accident occurs between 0 and 1, the expected distance, that's still 1/2.
Yes.
Okay, I see what you're saying. Plus here, oh, that should have been a 1, right? Because if this is the expected location of the accident, if it's between here, so the expected distance is going to be 1.
Yes, that's what I got.
Okay, good. It's not as big a mistake as I thought it was. Whoops.
No, I just wanted to make sure.
No, you're right. And I know when you speak, I have to listen. So I did rush through that one a little too fast. So I was a little too confident. Yeah, I'll get a note out about that.
All right, no worries. Thank you.
I appreciate, thanks for catching that. No, you're absolutely right. Darn it. This is completely what I forgot to mention is right there. And then everything is fine. Okay.
Yes.
Bye.
All right, thank you.
See ya. There we go. Got it. Oh my God, I am so unhappy with myself right now.